Okay, so as we discussed in class today, there are certain qualities that a good graph has. So if you look, I've got a set of data here that's answering the question, how does the time a tree grows affect its height? So the qualities of a good graph, it starts with a title. So I'm going to give you a title first. The title of this graph is always going to be the dependent versus the independent. So in this case, the dependent variable is height, so my title is height versus time. And maybe I want to put for a tree, just to give the reader an idea of what this graph is showing. My next step, so I've done my title, is axes labels. So I'm going to draw down, all the way over. I'm actually going to scroll down a little bit so we can see that better. There we go. So my independent axis is time, so I'm going to label it time in years. And my dependent axis is height, measured in meters. Then I've done step 2, evenly divided axes. So I need to get up to 5 years, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I have 28 squares and I need to get to 5. I want to use as many squares as possible, so I'm going to count by 5 squares. 1, 2, 3, 4, 5, and there's 1. 1, 2, 3, 4, 2, 3, 4, 5. So now I've used most of that side of the graph. My height goes up to 6, and I have well over 30 squares. So I'm going to go by 5s again. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so I've evenly divided my axes. Now I'm going to plot my points. The first point is 1, 2. So I go over a 1 and I go up to 2. And I put a tiny dot with, oops, what just happened? Undo. There we go. 1 over 2, tiny dot with a point protector. 2, 3, so I'm going to go up to 3, point with a point protector. 3, 4, 4, 5, and I just made this data up, which is why it's working out so nicely. And 5, 6. So now I've properly plotted my points. My next step is to do a line of best fit. Since I don't have a ruler that I can do this, I'm going to cheat a little bit and use my computer. So my line of best fit would look like, it's not going to do the greatest job ever, but this. And this needs to rotate this way just a little bit. All right, so now I've got my line of best fit. The next step is to find the slope. To do that, I'm going to choose 2 points. So slope, step 1, choose 2 points. And those points have to be on my line. So I'm going to go to my line and I'm going to find 2 points that are right on the line. So I'm going to choose this one right here. Oops, that's not actually even on the line. Oh no, there goes my line. Let's draw that again. So my first point will be right about, I'm trying to find some that are good here. My points are right on my line, so I'm going to choose that one and this one. This one is 2, 3, and this one is 4, 5. Step 2 in my slope is to calculate the slope. I'm going to show that work right on my graph. So if y2 minus y1 over x2 minus x1, I have 5 minus 3 over 4 minus 2. That equals 2 over 2. So my slope is 1 meter per year. Notice my slope has units. My final step then is to find the equation. Remember from class that we talked about how an equation is the y equals mx plus b is like a fill in the blank template. So my y, I'm going to use h for height, because that's a better variable, t for time. My slope m is 1 meter per year times time plus 1 meter, because this is my y-intercept. I didn't draw my line very well, but there's my y-intercept. Okay, so when you are doing graphing like this is the method you need to follow each time. The goal is to get this equation. If you're interested in doing some problem solving, I'm going to talk about that for just a second. It would be something like this. Let's say I have this equation now, and I want to know how tall is the tree at 2.5 years. So my time, t, is 2.5 years. I can take that then and plug it into my equation. So I use a method called equation substitution answer. And we'll talk more about this in class, but this is how I expect you to show your work. The equation is h equals 1 meter per year times time plus 1 meter. Substitution, I'll show that I put the t in, 1 meter per year, put in 2.5 years for t plus 1 meter. And my answer, the years cancel out. I get 2.5 plus 1, which gives me 3.5 meters. So that's how you do problem solving. And like I said, we'll talk more about this in class. But when I say show your work, I want equation, substitution, answer. Okay, so if you are still confused and have questions about how to graph data, find a slope, and write the equation, you need to schedule extra help with me. Remember that I'm available during my free periods as long as you email me or talk to me about coming in, but I'm also available every day at 3:15, okay? So Monday, Tuesday, Wednesday, and Thursday, 3:15 to 4 o'clock, I am either in room 316, which is our classroom, or 307, which is my chemistry classroom. You can find me in either place.